Circuit analysis. Circuit diagrams. Drawing realistic pictures of circuits can be very difficult. For this reason, we have common symbols to represent each piece. Here's what a real resistor looks like. Here's how we'll represent it on our diagrams. Here's a battery, and here's how we represent it. Please notice, here's the positive end. The positive end has the longer vertical line there. Okay, this is going to be your negative terminal, the other side. It can also be drawn like this. Sometimes people draw a couple extra lines in there. Wire is just going to be a straight line. Now, circuit diagrams do not show where each part is physically located. This is just the schematic. Draw a simple current that has a 9-volt battery with a 3 ohm resistor across its terminals. What is the magnitude and direction of the current? So we'll put our battery in first here, right over here on the bottom, and then we'll connect it up with some wires to a resistor, and then come back to the other side of the battery, where this is the positive terminal, this is the negative terminal. The longer line is the positive terminal. Now, in reality, that resistor may not be up there. Maybe it's down here. Maybe it's on the side. We don't care. This is just representing how the current's going to flow. So, the magnitude and direction of the current. Well, this is just Ohm's law. We have voltage and resistance. So I is V over R, 9 volts over 3 ohms. We have a 3 amp current. Now, the current flows out of the positive terminal. We're dealing with conventional current, which is the flow of positive charges. So that's going to come out here, go up here, and you can see we've got the little red line drawn there, through the resistor and back to the negative terminal. So conventional current leaves the positive side of the battery, comes back to the negative side. There are two ways to add a second resistor to the circuit. One is place them in series. In series, all charges in the current, here it comes out of the positive terminal, must move through both resistors to get to the negative terminal. They have no choice. Once they leave the battery, they have to go through both. With parallel, charges come up here. Some will flow through the bottom resistor, some will flow through the top, and then it'll all rejoin on this side and come back. So charges can go through either R1 or R2, but not both. That means it's a parallel circuit. This is kind of a tricky example, but the question is, are the following sets of resistors in series or parallel? The one on the left will be parallel and the one on the right will be series. Let's do the series one first. You have charges leaving the battery here, positive charges, and they want to get back to the negative terminal. So they go through this resistor and then through this one. So they have no choice. They have to go through both resistors. They didn't actually have to be drawn right next to each other, did they? No, we had one over here, one on top. That's okay. So let me just, so we can see that a little better. Now the parallel one might have tricked you a little bit. They're certainly not parallel as you learned in math, right? This is parallel in math. But resistors in parallel do not have to be drawn in parallel lines. They just need to provide separate paths for the charges to get from the positive battery terminal to the negative terminal. Okay, so all the charges come up to this point, then some will go through R1, the rest will go through R2, then back at this point they all join together and come this way until they get back to the negative terminal.